All right, so this is kind of round one of review, and this is actually an old quiz that we used to give to honors pre-calc. So our quiz is not, this is not a mirror image of the quiz, but a lot of these types of questions could be on there just in a more organized fashion. So most of this is non-calculator. What is the domain for this function? So any log or natural log function, remember the rule is you take the expression inside and set it greater than 0. And this is just a linear inequality, so I don't need a number line. I can just solve for x. Now remember, this says 5/4 is greater than x. That's the same as x is less than 5/4. If I would have kept the -4 on this side, when I divide by the negative, I would have flipped around the symbol. So -infinity to 5/4. A logarithm is an exponent. I've talked about that a few times in the notes. Every time we say a logarithm is equal to a number, remember the number represents the exponent. What is the range of this function? So for this function, if it helps, put the -3 on the end. I just used we use the commutative property that says we can just flip those around. So I would just think of a quick sketch of this. It's the 2 to the x graph, but it's been shifted down 3 units. It kind of looks like this. So it's that shift of down 3. Normally exponential functions are 0 to infinity. This one is, the range is -3 without hitting -3 up to infinity. Write this in log form. So log base number is 5 of the result, which is 125, equals the exponent, which is 3. What is the asymptote of this function? So this function has been shifted to the left 2. Again, you could sketch this if you wanted to, but we've been shifted to the left 2, so that's where the asymptote's going to be. But otherwise, remember, you've got nice points 1, 0, 6, 1. You really don't need all of that information to figure out the asymptote for this, but might as well do a quick little graph thing here. So anyway, the vertical asymptote is, make sure you make an equation, x equals -2. Back to domain like number 1. So remember the rule was take the expression inside of the logarithm and set it greater than 0. And if you have something that's not linear, so it's quadratic or high degree polynomial or rational, you need a number line. So we get critical numbers. What makes this function equal to 0? We put them on a number line. And we either think about the graph of x squared minus 9, or we test 3 numbers. Remember, the graph is the easiest thing to do for quadratics because it's just a parabola, so plus, minus, plus. And we want the positive sections. So this domain is -infinity to -3 and +3 to infinity. What is the asymptote of this function? So again, you could look at this as natural log of x plus 3 is on the end. So it's a natural log graph. It's been shifted up 3 units. That doesn't change where the vertical asymptote is. So it's still x equals 0. If you want to graph the thing, you could. Something like this. What is the asymptote? Notice how it's not saying vertical or horizontal. That's something that you need to know. It's vertical when we have logarithms, but it's horizontal when we have exponential functions. Excuse me. So y equals e to the x is this graph, and its horizontal asymptote is y equals 0. What is the x-intercept of h of x equals 3 plus log base 3 of x minus 1? So we've had this in a textbook assignment. We had this on a worksheet last week. Here it is again here. I have a lot of people like asking me as if it's the first time they've seen this about x-intercepts every time we see it in a homework or in notes or whatever. So a reminder on how to do this. And you can go back to, like I said, the the night that we graphed these log equations, that textbook work, or the worksheet that I gave you on Thursday, I think it was. An x-intercept for any function is set the function equal to 0 to begin with. Okay, and then the next step is to get the log by itself. And then to start solving for x, because we haven't solved log equations yet, but we do have the skill of write this log equation in exponential form. So kind of like what you did for number 5. Start with this log equation over here and go back and write the exponential version. So if I do that here, the base number is 3. We're raising it to the negative third power, and we're getting the result, which is x minus 1. So 3 to the negative third is 1/27th. And then you add 1 to that. So 1 and 1/27th. Or it's weird to have mixed numbers, so I'd say 28 over 27. So this is 28 over 27 for your x value. That's our x-intercept. So same thing for this next one. Set the equation equal to 0. You do need to get the log by itself on one side and make sure there's no number in front. So I'm going to add the log base 3 of x to the left side. And then write this in exponential form. So base 3 to the 4th power equals the result, which is just x. So x equals 3 to the 4th, and 3 to the 4th is 81. If you don't know your powers of 3, pick one you know. I think we all know 3 to the 3rd is 27. And then if you're trying to figure out 81, 243, whatever, just start multiplying by 3 and see what happens. Okay, true or false. We had this on last week's worksheet. And the way to determine this, in my mind, is pick the side that looks familiar and either condense it or expand it if you're having trouble. Like, we don't have a rule for expanding x plus 3. So first of all, I know 11 is false because there's no way to expand that. But also, I know that natural log of x plus natural log of 3, it should be the natural log of x times 3. It shouldn't be x plus 3 on the inside. So that's why it's false. Number 12, we had something like this on our worksheet. Dividing a log by a number is the same as saying 1/4 times that logarithm. So log divided by 4 is the same as 1/4 times a log. And that is our exponent rule, right? The 4th root of a is a to the 1/4. So I could say that this is true, and that is equal to log base 3 of 4th root of a. Now, I'm showing a bunch of work just to kind of explain why these things are true, but you don't have to show work for these. This could just be true or false. On the worksheet we did last week, it was like rewrite it to make it true. I was just trying to get you to try to do some work if you could. 11 is like 13. There's no way to expand an a minus b, so I know that 13 is false. What it should be is the log base 2 of a divided by b if we're subtracting two logarithms. All right, and then let's see if this is true. So we've got a b and an a, so there's addition going on, so that's right. A is to the 1/2 power, so there's a 1/2 out in front. And b is to the 3rd power, so there's a 3 out in front. Yeah, so that one's true. All right, now this is kind of tricky. The natural log of 1/2, is that the same as natural log of 3 over 6? Because like 3 over 6 divides out. Natural log of 1 divided by 2 could be natural log of 1 minus natural log of 2. Anytime I see a natural log divided by a natural log, or a log divided by a log, you could say change of base. That means log base 6 of 3, but that's still not equal to the natural log of 1/2. So there's no way to, you're not allowed to divide the natural logs like that. If there's division here, you're not allowed to say it's division inside of a natural log. So this is false. All right, this one, log base 5 of A minus log base 5 of B, is that equal to, it should involve division, but does it involve division of 2 logs? No, again, this is like a change of base formula. What it should be is the log base 5 of A divided by B. So basically, if we have addition of logs or subtraction of logs, we will only ever have division inside of a logarithm. It'll never be log divided by log. That's only change of base. All right, so this was false. And let's see, this one, I'm looking at the left side and saying, well, this could be A cubed. And this could be B cubed. And can we get it to look like that? Well, yeah, we would multiply those, A cubed, B cubed. And A cubed, B cubed is the same as A times B and then cube the whole thing. That's the same. So yeah, this is true. All right, so true or false section can be tricky. Pick a side that you know that you can either expand or condense and see if it, do the expansion or condense, I don't know, condense or expand it, and then see if it matches the other side. Right, this one, we have division inside of the log, and we switch that out to subtraction. That's true. Anytime I see log divided by log, I think change of base. So let's look at this over here. This would be the log base 3 of 9. Is that equal to 2? Yes, because 3 squared equals 9. So this one's true. We have no rules, not change of base, not expansion or condension. Condension? That's not a word. Anyway, not expanding or condensing that causes us to multiply logs. So anytime you see log times log in this true or false section, that's got to be false. What it should be is the natural log of 5 plus the natural log of x. All right, now 21 is sort of like almost true. This expression here, the squared is only on the b. So this is log base 3 of a and then times b squared. And here, the squared would go on both the a and the b. A squared, b squared. So this is false just because we're missing some parentheses there. All right, let's look at this one. First part seems totally fine. Log base b of a to the third would become 3 log base b of a. And then plus log base b of b to the third. Now we've had these before in those like problems on the previous worksheet where it was like right in terms of a, b, and c. And then I had lots of log base a of a. So if these base numbers match, that can be simplified to 3 right there. So yes, this is true. And our final one, natural log of 3x is natural log of 3 plus natural log of x. That's true as well. Okay, I think true and false section can be pretty hard. On this old quiz, that was the section where people tended to struggle because it can get confusing. So that's about just practicing and memorizing your 4 basic properties, the product, quotient, power, and change of base. Graph each function include at least 2 points and an asymptote. So you need to know the difference between your exponential and your log. So first of all, exponential nice points are 0, 1, 1a, and y equals 0. And then for log, nice points, flip everything around. 1, 0, a1, x equals 0. That's something to study before our quiz. So this is exponential. This graph has been shifted up 2 units. So the original points are 0, 1, 1, 3, and y equals 0. And then we're going to go up 2. So that's going to move y equals 0 up 2. So draw in your horizontal asymptote. The point that was at 0, 1 goes up 2. And the point that was at 1, 3 goes up 2. And then you sketch in a smooth curve for the exponential graph. The next graph is log base 5. So the original nice points are 1, 0, 5, 1. This has been shifted to the left 3 units. So when we go left 3, that's going to move the vertical asymptote from 0 to negative 3. So x equals negative 3. And then the point that was at 1, 0, go left 1, 2, 3. The point that was at 5, 1 goes left 1, 2, 3. And again, we sketch in a smooth curve. You need to know the general shape of an exponential as well. Looks like this. And the general curve of a log graph looks something like that. All right, 26. I always like to spin this around so it's in a form I'm used to. So I'm just putting the positive 4 on the end, keeping the negative log. So this is a log graph again. Color code these actually. So the nice points originally for base 2 are 1, 0, 2, 1, x equals 0. The negative on the outside is an x-axis reflection. But what that means is that we're going to do x negative y. So apply that reflection. 1, 0, 2, negative 1, x equals 0. And then the plus 4 is up 4. So you're going to add 4 to each of these y coordinates. So x equals 0 would still be at x equals 0. 1, 0 moves up 4 units to 1, 4. 2, negative 1 goes up 1, 2, 3, 4. So it should be here. And then this graph looks like this because we have an x-axis reflection, so it should be upside down compared to what a normal log graph looks like. All right, and then here we have 2 to the negative x plus 4. So this is exponential. So first of all, the nice points are 0, 1, and 1, 2, and y equals 0. This negative x is a y-axis reflection, but that means you're going to do negative x, y. So 0, 1 would still be 0, 1. 1, 2 becomes negative 1, 2. Y equals 0 remains the same. And then all of those need to go up 4 units. So y equals 0 is going to go up 4 to y equals 4. 0, 1 is needs to go up 4 units. So 1, 2, 3, 4. And then negative 1, 2 goes up 4 units like that. This exponential graph that went through a y-axis reflection should be a decreasing function. So you go to the right, and that's our final graph. Okay, the evaluate section. So this is again like Thursday's worksheet where we had, and Friday's worksheet where we have just a lot of little things to simplify. So remember, evaluate mostly means what's the exponent. And I think my directions usually say evaluate and simplify because sometimes you're using properties or you might still need to condense first and things like that. We can get no solution for some of these. So log base k of k to the fourth is saying k to what power equals k to the fourth. That answer is 4. Some of you are also thinking of it as like log base k cancels out base k. That's totally fine too. Know the difference between natural log of v and natural log of 1. Natural log of v is 1. Natural log of 1 is 0. Because this is saying e to the what equals e, and this is saying e to the what equals 1. We can't log a negative. There's nothing I can raise 2 to get negative 4, so that's no solution. Log of 10, remember there's a base 10 under here, so that's 1. 2 to what power equals 1 over 32? It's got to be negative to make 2 into a fraction, and it's 2 to the negative 5th. If you see a root, remember that's the same as a rational exponent. It's the same as saying log base 3 of 3 to the 1/5, so the answer is 1/5. 4 to the log base 4 of 15. The 4 and log base 4 cancel out, and you've got 15. 35. This is one that was commonly missed on this quiz. Remember, anytime you see a log over a log or a natural log over a natural log, that is the change of base formula. And so what that means is we should write this as the log base 2 of 16, and then it's something we can evaluate. 2 to what power equals 16? The answer is 4. Also, anytime we had this on a worksheet too, anytime you see two logs being multiplied like this together and you can't simplify the logs, like 2 to what power is 9, 9 to what power is 8, that's also change of base formula. So remember how we did this. Log of 9 over log of 2 times log of 8 over log of 9. Log 9's cancel, and that's log base 2 of 8. Someone in one of the classes, I can't remember, when we first did this, they said, oh, so is it, if it's in this format, is it just going to be like this, log base 2 of 8? And that answer is yes. I've got these set up so that these two logs are going to be the ones that cancel. And so you've got your base number. So it's good to write it out just in case the things that cancel are these two diagonals or something. But otherwise, yeah, you get log, sorry, I should have written this before. You get log of 8 over log of 2. Reverse change of base again, just like 35. That's log base 2 of 8. And so that answer is 3. Okay, 37. These two logs are base 10. So I always check to see, can I simplify them? Like 10 to a power is 4? No. 10 to a power is 250? No. So that means you should condense first. Let's see, 25 times 4 is 100. So 250 times 4 is 100 with an extra 0, 1,000. And then powers of 10, just count the zeros. 10 to the third is 1,000. This one's weird. Log base q of q to the q. So again, some of you are thinking of this as log base q cancels out the base q. You're left with q. Or you could be saying q to what power equals q to the q. Now my q's look weird. So the answer has to be q. All right. We've had something like this on a worksheet too. What do we do if there's like a square root and I can simplify this? Well, this can all be simplified pretty nicely. Like 4 log base 3 of, what is the square root of 81? It's 9. It's not plus or minus because the square root is built in. So it's just 9. Plus log base 2 of 4. Well, log base 2 of 4 is 2. So that's fine. Do I actually need to calculate 9 to the 4th? No. Because remember, our goal is just to figure out what is the exponent on 3. So rewrite 9. 9 is 3 squared. So you're raising 3 squared. You're raising a power to a power. So we multiply those exponents. Log base 3 of 3 to the 8th plus 2. Now I can see that that's just 8 plus 2. So 39 is 10. Right, if I take a look at 40, I'm going to switch colors so my work doesn't mix together. I can't simplify these individually. 16 to a power is not a nice answer for 40 or 10. But I can condense this. Log base 16 of 40 divided by 10. So log base 16 of 4. 16 to what power is 4? 1/2. E to the natural log of 1 is 1. E to the natural log of 8 is 8. E to the natural log of e is e. 1 plus 8 is 9 minus e. That's as far as we can take that one. 3 to the what is 81? 4. Natural log of e squared is 2. 4 to the 16 to the third. So again, don't figure out 16 to the third. Rewrite this. 16 is 4 squared. 4 squared to the third. is, hold on, 4 plus 2 is 6. And then minus log base 4 of 4 to the 6th. There we go. So we get 6. This looks like a negative sign, but it's not there. We get 6 minus 6, which is 0. We've had problems like 43 on our worksheet before. Again, be careful of this. This is not 28 minus 7. The rule for the property that we have is that you just have one logarithm. So you have to condense this first. 2 log base 2 of 28 divided by 7 is 4. And then 2 log base 2 cancels, and our answer is 4. Okay, 44. Log of 4 plus log of 25. Can't do anything with those separately, but I can condense them. That's the log of 100, 4 times 25, plus 2 to the third is 8. The log of 100, because this is base 10, is 2. 2 plus 8 is 10. 1/2 minus, you could rewrite this as natural log of e to the 3/4. So we've got to do 1/2 minus 3/4. That's 2/4 minus 3/4. So negative 1/4. Okay, log base 2 of, so let's figure this out. Log base 2 of, instead of 16, it's 2 to the 4th to the 3rd. Whole thing will be divided by 6. Log base 2 of 2 to the 12th over 6. So log base 2 of 2 to the 12th is 12 over 6 is 2. And just to finish it off, a logarithm is an exponent. So every time we're evaluating these logarithms, we're figuring out what the exponent answer is on the result. Okay, expand each logarithm. Remember, you should have however many different variables or numbers you have, that's how many logs you should have. You can do this in one step if you want to. I'm just rewriting for this video. So this is x to the 3/2, log base 3 of x to the 3/2. Because we're dividing by both y and z, we're going to subtract each of those. Minus log base 3 of y to the 4th, minus log base 3 of z. Make sure you write the base number for all of these. And then the final step for expansion is to pull the exponents out in front of each logarithm. So 3 over 2 times the log base 3 of x minus 4 times the log base 3 of y minus the log base 3 of z. And this one, we have an x plus 1, a w, and a y. So natural log of x plus 1, there's no way to break that up further, plus natural log of square root of w, or w to the 1/2, minus natural log of y to the 3rd. And then just take care of the exponents. So again, natural log of x plus 1 cannot be broken up into natural log x plus natural log 1, plus 1/2 natural log of w minus 3 natural log of y. Going the other way, to condense, move numbers that are in front of the log, which this is a 1/4 in front of your log. Move those to become exponents. So we have the log base 2 of x to the 7th plus the log base 2 of 81 to the 1/4. And you should always be suspicious of numbers here, right? Like 81 to the 1/4, that's the 4th root of 81. 81 is 3 to the 4th. So I do want you to simplify numbers if you can. So this is the log base 2 of x to the 7th plus the log base 2 of really just 3 instead of 81 to the 1/4. And then condense that further. So the log base 2 of, you could say x to the 7th times 3, but that looks weird. So I'm going to say 3 times x to the 7th. The order doesn't matter there. And just like in 50, divided by 4, again, that just means these are all underneath a big 4th root. So you could write this so that they're all to the 1/4, or you could just say, like, I'm just going to do this. Put my exponents on first. I do not expect you to calculate 16 to the 5th. Just write it as 16 to the 5th. So natural log of 16 to the 5th times x to the 3rd divided by x plus 1. All of that has a 1/4 out in front, or divided by 4 still. And so I'm just going to put a big 4th root on this whole thing. And again, just leave it 16 to the 5th, x to the 3rd over x plus 1. We could simplify 16 to the 5th, I guess. Let's see. 4 squared to the 5th. It's 4 to the 10th. I'm not going to have all this extra work, but it's good to look at. 4th root of 4 to the 10th. Well, 4 to the 10th is 2 squared, right? So 2 squared to the 10th is 2 to the 20th. Now we're getting somewhere. 2 to the 20th over 4 is 2 to the 5th. So I guess that does simplify. That's kind of nice. We can pull a 32 out. The 4th root of 16 to the 5th is 32. And then there's a 4th root of x to the 3rd over x plus 1. So I don't have all of that simplifying. I would take either one. And the way I wrote this is weird, so let me do that. 32 times that. I would take either one of these. I'm not really testing you on your exponent rules there, but it's good to be able to do all of that work. All right, and then this one, again, we had this in our first logarithm textbook assignment. We had this on a worksheet. And so if you're like, this looks totally new, I've never seen this before, make sure that you are doing your homework and checking your homework and making sure that you're actually paying attention to everything you're doing, because we've had this like 3 times now. So rewrite in terms of YES means expand, rewrite the numbers if needed. Like we had bigger, ours was harder on the worksheet. We had bigger numbers to work with. We'll break down 6 and 7 if needed. You might need to expand again. And then your 4th step should be sub in letters for logs. Okay, so following my first steps, expand. Log base b of 6 minus log base b of 7 minus log base b of b squared. Expand, done. Rewrite numbers. We have log 2, log 3, log 7. So this log 7 is fine. This log 6 needs to be rewritten as 2 times 3, or 3 times 2, whatever. And then also be on the lookout for bases that match. Log of lowercase b, log base lowercase b of b squared is 2. So always be on the lookout for those. All right. 3rd step is to expand again, because 2 times 3 can be expanded out into the log base b of 2 plus the log base b of 3. And then the 4th step is to sub in your letters. So log base b of 2 is y plus log base b of 3 is e minus log base b of 7 is s. And then the minus 2 just gets tagged on. So y plus e, hold on, write this so it doesn't look so weird. Y plus e minus s minus 2. That's our final. Final answer does not have logarithms in it. We're subbing out the letters for what the logarithms were. All right, that's it for the non-calculator part. And then the calculator part, there's not much to our calculator part. Most everything we've done is non-calculator. So evaluate and round to 3 decimal places. I can use change of base for this, log of 14 over log of 7. Or I think I showed you, math further down is log base. I don't mind if you use this because it's there. Why not use it? This is saying 7 to the 1.356-ish power is 14. But like I said, if I did it like this, I get the same answer. If I use natural logs, I get the same answer. So the change of base formula gives us the answer if we can't find it in our math menu. So 1.356 is what I'm going to approximate this to. All right, the next one, evaluate this for t equals 4. So this is just, can you correctly type this into your calculator? Negative 2 times 4 is negative 8. So when I type this in, I need parentheses around the denominator, so my calculator knows that all of that is down there. So 200 divided by parentheses, 1 plus e to the negative 8. So I'm getting 199.933. Log of 280, there's no change of base needed there. 2.447. This one needs parentheses around everything. 15 plus 2 e to the 0.5, there's the top, divided by 3 ln 6 plus ln 5. This 619 would round up to 620, so 2.620. Natural log of the square root of 20. 1.498. Right? You invest $7,500 compounded monthly, n equals 12. At this interest rate, r equals 0.0375. What is the amount in your account after 20 years? That's t. So you need to know your interest formulas. This one is 7,500 times 1 plus 0.0375 over n, which is monthly, to the nt. Most common mistake is putting to the RT or messing up your decimal for R. So for this, I'm going to round to 2 places because we're talking about dollars and cents. So 15,858.94. Make sure you label it with dollars. We always have to label our answers. And for this one, an amount of $2,400 is deposited in a bank paying an annual interest rate of 2.25% compounded continuously. So R is 0.0225. Find the balance after 15 years. So this formula is PERT 2400 times e to the r t. T is 15. So I'm just typing this in and making sure I'm doing it carefully. 3,363.46. So 3,363.46. Did I say that right? Yes. Again, make sure you label with a dollar sign. Yeah. On our review for Wednesday, the only other calculator problem that we'll practice, because to be honest, I'm not going to have you just typing in a bunch of random stuff like this. That's our old honors class. We will have compound interest, and then you might just have any other exponential formula like we had in our notes, and you'll be asked to plug numbers into it, or excuse me, maybe set the equation equal to a number and figure out like how long until we get to 3,000, something like that. All right, that's it for this worksheet. I have office hours Wednesday if you need to come in and get some help.